I think that in 10 years' time, this will be the expectation of a runtime, is that it will have structured concurrency. I think any new language that's going to come out after the next couple of years will have structured concurrency in it.
Hello, welcome to DevTools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. I'm really excited for today's episode. So we have Charles Lowell on. Charles, you created a consultancy called Frontside. Want to talk about that, but you're working on this open source library called Effection, which is incredibly exciting to me. So excited to talk about all that. But before we dive in, would you like to tell our listeners a little bit more about yourself?
My name is Charles Lowell, and I've been doing development for a very long time. I guess it's hard to think of it because I don't really conceive of myself this way, but I am, spiritually and literally a graybeard. I'd say I've been writing code now for about 30 years, and I'm the founder of the Frontside, although I still write code every day and work with our clients every day.
Sweet. So let's dig into Frontside a little bit. It looks like it's a consulting company that does a lot of open source. Can you tell us how you got into that and the types of open source projects you guys focus on?
Yeah, so we've been doing open source kind of throughout the history of Frontside, but Frontside started back in 2005. So this will be our 20th year in operation. And up until that point in my career, I had been working almost exclusively on the back end. And I started doing a lot of web apps and Rails apps. And one of the things I realized is so many of the architectural patterns that I had been using on the back end were directly applicable to the front end, and which was, at that time felt kind of like a little bit of a Wild West, especially on the web. There's just, you've got this very new thing called dynamic HTML and JavaScript to control it, and hey, go have fun. And so the front side was the word means taking those architectural patterns from the back end and applying them to the front side. And so that really was kind of the inception of the company. And since then, we've actually swung, I would say, a couple of times back to the back end and back to the front end, because that's just kind of the way things happen. It turns out that the architectural patterns that are developed in both of those contexts are almost always eventually applicable in the other. And so the things that we would learn on the front end, we end up taking the back end and vice versa. And so we've been going at it for about 20 years, and we've worked on a bunch of different open source stuff in that time. So originally, I think we were primarily in the Ruby community. So if you go into you'll find that we have a lot of gems. Probably our most popular one is the one that integrates with Stripe. We also did, as we were working on the front side, the original implementation of the JavaScript integration gem. So we actually took V8 and embedded it into Ruby so that inside of a Rails application, you could compile assets and evaluate JavaScript code all without leaving Ruby. And so that's kind of now that's a more independent project, but we were the ones who started that. We also were very involved in the continuous integration and continuous delivery. That's always been very important to us, especially from the beginning. But being primarily a front end consultancy at that time, we actually designed the artwork for the Jenkins project. If you've ever heard of that. So we were very big into the Jenkins community, and we were actually brought and did the same thing. There's a lot of taking other runtimes and bringing them into other runtimes. We took Ruby, JRuby, and let you write Jenkins plugins inside Ruby. And if there's one kind of tying theme for the company, is that we believe very strongly that when development is done right, it feels like flying. There's no better feeling. You are commanding bits and bytes from great heights, and they're doing everything that you want almost effortlessly. And so that's what we're looking for in terms of a developer experience, whether you're on the front end or the back end. And so that's what we try and bring to our clients.
I thought it was pretty interesting, like going through your landing page where you were like directly offering developer experience, like consulting as a thing. When I think about a lot of traditional consultancies, I guess I think more agency. Not having worked in this space, where it's like a customer comes to you, is like, "Hey, I want to build this thing," et cetera, et cetera. But this is like, let me come in and speed up and just like improve the feel of your developer experience so that you can ship faster and like, have closer iteration cycles. So like, was that, is that something that formed over time? Were you doing that in the beginning? Like, how did that come about?
I think that's something that formed over time. Originally, we were very much an agency. We were building web applications, first in Rails, then in JavaScript. We even did some Java and C++ for desktop applications. We were very much the model of tell us what your problem is, and we will build you a product that solves that problem. But I think we started doing DX consulting about 7 or 8 years ago because time and time again, when we're in especially very large companies that have very large development teams, we would see that so much money was being wasted on friction, like unnecessary friction. So you have these teams that are trying to essentially move a product down the road, and unless you've got wheels, unless you've got grease on the ball bearings, you're just going to be sitting there expending this massive effort to just go a few inches. And so the underlying problem wasn't really a missing tool. It wasn't really a missing application. It wasn't even a organizational structure like an agile team or something like that. It was really just there's so much friction in your tooling. There's so much energy being lost in meaningless tasks. Let's focus on the developer experience, and then you can reclaim that money by having your developers being able to work without friction so that they can accomplish their task and it feels easy, it feels great. And that turns out that's a product.
Yeah, so reading through your website, it feels like where that has productized is into Backstage. Can you give us like a little overview of like what Backstage is and how it accelerates that development?
Yeah, so Backstage is a developer portal. It was originally developed at Spotify, and it is just a way for very, very large teams to share information, to share processes, to just not reinvent the wheel time and time and time again. So at the very kind of minimum installation of the product, it will crawl your GitHub organization and just make sure that every single person in the organization understands what kind of intellectual property exists throughout the organization, and then it inverts the control so that if you have a GitHub repo, all you have to do is check in a YAML file, and it will tell Backstage, this is my project, this is how you integrate it, and you can register your documentation so that you can have a single documentation site that's searchable, and so on and so forth. So, like you guys, mentioned meeting through a GitHub repo, it's kind of this trying to establish a very similar thing for people in organizations, so that if you need something, you're much less likely to invent it on your own. Or if you need, say, documentation, you don't have to DM someone on Slack and say, "Hey, how do you do this?" You can just look, and it's there publicly. So all of that is part of removing that friction. So it's kind of I think it's an important piece in the toolkit, especially for very, very, very large. I mean, we're talking development teams over 500 people. You start to experience a lot of loss of people just not knowing that there's an off-the-shelf component that they can reuse that's right inside the organization.
Yeah, absolutely. I'm surprised that Backstage has like blown up so much. Well, not surprised as in like, oh, it's not good, but like I'm just surprised. Like it's a really cool thing. So when I was working at Artsy, I think that's when it came out, and we had this sort of similar problem. It was like, if you get a large enough organization and you have teams that are spinning up services, they like need to learn all the things that they need to learn to like spin up a service. And it was cool that Spotify had like open source this product where it's like, you need to spin up a service. Here's like a one-click feature. We'll show you the catalog of like kinds of services you can operate inside our organization. Yeah, I don't know. That's really cool.
Yeah.
It's also that you're offering this help, integrating this open source project, and helping accelerate people's developer experience. And so we really want to talk today about like some of your open source projects. But before we move on to that topic, I just wanted to ask a question: is like, how do you balance time between paying consultant work and open source?
That is a very, very very good question. I don't know that it's a difficult problem associated with that question. And I can tell you what we do. I don't know if it's optimal. So first of all, there's just, this is especially when I was younger and not so much anymore. There's just like, you put in extra hours after work. Now I don't do that so much. But when it's really working, the open source work is very much on the long end of the development cycle. And what I mean by that is, we'll go into a client, we'll do some work, we'll go in again, do similar work, we'll go in 3-4 times and say, okay, I see a pattern here. And it can be, it can be difficult. You want to resist when you're working with a client to say, like, I'm going to build you a framework, because really what they want you to do is they want you to solve an immediate problem that they have. But once you've solved the same problem 4 or 5 times, then it can be very easy to, like, in between projects, say in like, a 3-4 week time period, like bang out a prototype, which is not quite a framework at that point, but it means that you're going to be able to use it on the next project. And even though you're not really introducing a framework, what you're doing is you're solving their problem that that they're going to have already a lot more quickly. And then you take that, and then, so you kind of have a proof of concept, but you're not really promoting it as an open source project. And then, you evolve it. At some point, you're like, wow, okay, this is, you have, maybe 5 plates like this that are spinning, and then you realize, okay, this one's special. There's something about this that really needs wider adoption that people could really, really benefit from. So I would say, in answer to the question, the only solution that I've really found is you have to be really patient, and you have to be very not rushing to try and make the end all be all solution. You really have to let it emerge over time. And sometimes that can take a very long time. I would say in the case of Effection, it's, almost 7 years, and multiple versions. But I do feel that we really have locked in on something that is very, very beneficial.
Cool. That's a great segue into talking about Effection. But before we do that, I think we need to set the stage a little bit and talk about structured concurrency and what that actually is and why I should care. So convince me.
Okay, convince you. So first of all, let me just start right from the top, is that I would recommend for you and for all the listeners, and really just anybody doing programming, or is to go ahead and read the blog post that kind of started, at least it might not be the one that coined the term structured concurrency, but I would say it was the one that brought it to prominence. And it's, for me, I can count on one hand the number of blog posts that have kind of changed my life, and this is one of them. And I wish I knew his name, but it's the author of the Python library Trio, which is a structured concurrency library. And what he argues in that article, which is such a great mix of being academic yet very approachable, so it's very thorough, very well annotated, but it's, a very accessible argument. He talks about what makes abstraction possible, and he talks about the original conception of structured programming, which we all appreciate structured programming now because it's like a fish. It's the water we swim in. It's like us, it's the air we breathe. We don't think about the guarantees that if statements provide, that while loops provide, that functions provide. But he encourages us to think about that being a revolutionary idea in the 60s and early 70s, where if you enter a curly block, that control will pass out towards the end of the curly block. So if you enter an if statement, by entering that curly, you will exit, control flow will exit through the curly. Same thing with a while statement, same thing with a switch statement, same thing with a function call. And what this does is it allows us to make abstractions, because when I call a function, for example, I know that the only place that I can return is to that function site. And so it means that I can build abstractions on this function, because before the existence of structured programming, if you were to call a subroutine, that subroutine could like jump to somewhere else in memory and start executing instructions, and you might never return. And so it's just you can kind of leak flow control. And so what the concept of structured programming is at its core is that you want to, or that is tying the lifetime of concurrent processes to a lexical scope. And what that means is literally what you see is what you get. So if I'm looking at a piece of my program and I'm looking at a single lexical scope, I know that everything that I create in there is going to be gone after I exit that lexical scope. And this is something that's applied not just to flow control, but it's very familiar to us in terms of memory. So we don't have to, this is not like when we're writing JavaScript or we're writing Java or we're writing Go or literally any kind of modern programming language. When you allocate a variable, you don't have to think it's, if you allocate a variable inside of a function, you don't have to deallocate it, because you know that once it passes out of scope, if you're using a garbage collection system, it's going to notice that it's not part of the root set anymore, and the garbage collector is going to reclaim it. If you're doing something like Rust, it's going to say, okay, this thing is there's no owner for this object. We're gonna destroy it. And so this is the same thing for concurrent processes. So every concurrent process in a structured concurrent system is going to be bound to a lexical scope. So when I exit that lexical scope, that thing is not going to be able to survive. And I won't be able to exit my lexical scope until all the processes are finished. And why that's important is it just means that you want two things. Kind of the superficial reason is that you can't leak resources because every resource has a very, very delimited lifetime. And then I would say the bigger thing is you can build abstractions around it, because every single operation is atomic.
I think it's worth like talking about the native JavaScript stuff or the places in native JavaScript where you're running this problem. So promises aren't actually that great of an async concept, and it'd be nice to talk about a little bit more about that. And then you were talking about cleaning up resources. So there's a new spec for the what is it?
The explicit resource.
Yeah, so we have like some new tools to sort of help do that. So if it's like you're allocating something, you want to deallocate it out of scope. But historically, we haven't had that, and it's been really easy for, you don't close the database connection when you thought you should have, and then something blows up later. So whichever path you would like to talk, if you want to talk about like cleaning up resources or maybe promises, because that's something general, I think either of those I think would be really good to dig into a little bit.
Okay. So we can talk about cleaning up resources. So in Effection, and I would say in structurally concurrent systems in general, you not just a task or a promise or some concurrently executing code, but literally everything that has state is associated with that lexical context. So it's like a variable that's allocated on the stack. And when the stack is popped, you make sure that resource will be cleaned up. And I will get into why the explicit resource management and async await are really not adequate and up to the task, which is why other language runtimes are not adopting them. You'll notice that is unique to JavaScript, and nobody else is doing that. So allocating a resource really is just like allocating a variable on the stack. But it's more than that too, because you have to be able to handle things like errors in a uniform way. So if I have a scope that raises an error, I need to make sure that that error is caught. This is actually a problem in async await. And if you go out there, you can see a lot of people, like if I do a promise.race and I'm racing 20 promises against each other, and one of them fails, what am I doing? What do I do with the other 19? And the answer is they'll just keep running. You've basically leaked those processes. So this is one thing you can look at when you see a promise.race, you're almost always looking at a memory leak. And the most insidious thing about it is this memory leak doesn't actually appear until you're at scale, because it's not leaked outright, in the sense that eventually, probably, maybe, these promises will resolve. Maybe they resolve after 10 seconds. Maybe they resolve after 10 milliseconds. But they're still kind of out there hanging in the ether. And if you're in development and you're only handling a very small request load, or your event stream is just a trickle, it's not going to be a problem. You're not going to see it. It's not going to have a large impact in your memory relative to the total impact of the system. You take that same code and you put it under really heavy load, and your event stream is more of a fire hose. Then all of a sudden, each event leaking a small amount is still going to really, really stack up. And so one of the things I think that we fight against most when we're trying to evangelize this approach is getting across the idea that you don't always see these problems until it is way too late to fix them. And you're in production and you're handling a big load and you're like, oh my God, I'm leaking all this stuff all over the place. It's the same thing happens with a promise.all, except in the error case. So if I'm awaiting 20 promises with a promise.all and one of them fails, then I'm going to throw the error immediately, and the other one, the other 19 are leaked. So the race, you get the positive case, one resolves, you leak the 19. One fails, you leak the 20. Although I guess race is both positive and negative. So that's one of the reasons that our primitives and async await really aren't adequate. So whereas Effection, you are forced to handle every error. So if any of those concurrent operations fails, it's going to percolate up the stack. The other reason, and this is a really, really big reason, is that there is no way to resume or reclaim control of an async function once it is awaiting a promise. And this is really the most fundamentally broken thing about async await, is that if I have an async function and I say await new promise and that promise never resolves, I have leaked that async function. So you have no control. So whenever you await, no matter how long that thing takes to run, maybe it could be 5 years that it takes that promise to resolve, the async function that is awaiting that promise cannot resolve. It cannot settle for 5 years. And that's an extreme case. But again, you have the same case where that's extreme. But again, you have the same case, whereas if you're awaiting a lot of promises and they're taking a long time, there's just no way that you can back out. And so everything in that chain of causality is also leaked. So I could have a promise, I could have a call stack that's including a module from NPM, that's including a module from NPM, that's including a module from NPM, and inside there, it's got a promise that's not resolving, and that's going to cause everything up the call stack to leak. So one of the requirements of structured concurrency is that the lifetime of an asynchronous operation has to be controllable by the outermost scope, not by the innermost scope. And that's the problem with async await, is the lifetime of an async operation is determined by the lifetime of its innermost promise. Whereas in Effection and other structurally concurrent systems, the outermost operation, the outermost async operation has control to say, nope, we're done here. I don't not need it anymore. And you just fold up everything from down on down. And so it doesn't matter what's going on at the innermost level.
Yeah, it's such an insidious problem too, because like you just can't see it. Like the code, you look at it and you're like, this looks fine. Like I'm using JavaScript primitives, I'm catching errors and everything, and then you have these just problems kind of laying in wait, and that's like multiplied
Hmm.
if it's like there's like multiple functions between you and that promise.
Right, right. It is really bad, and so I think part of the problems with the explicit resource management proposal is that it doesn't address this underlying mechanic, which is that the when you're awaiting a promise, if it doesn't resolve, you're stuck, and so by relying on the async await as its kind of underlying cause, or sorry, its underlying mechanism, it's subject to this whole thing. I also think that there are problems in that it's optional. So not only can you get stuck because um, not only can you get stuck because there's a promise that's kind of gone rogue, but you can also get stuck because you forgot to declare something with using. And so, kind of what I would foresee is that we're going to have a new ESLint rule that is like don't use const, don't use let, use using for everything. Which is kind of silly, right?
Yeah.
But that's the only way to enforce safe. Like it's the only way you can be safe. Um, and so I think the optionality is a little bit strange, and just the syntax is extremely complex. So I don't even remember, but if you look at that table, you've got like for using await, for await using, const using. Like it's. I mean, it's almost impossible to comprehend, and I think that's also kind of touches on an adjacent problem, which is the async await splits the entire JavaScript ecosystem and API surface into a false dichotomy of synchrony and asynchrony. So one of the things about Effection is that if a operation is synchronous, it will resolve synchronously. The only time that it resolves asynchronously is if it's actually waiting for something. And so what that means is, unlike async await, you can use Effection for an event handler. So one of the reasons you can't use async await for an event handler is that cancellation and prevention of defaults is a synchronous operation. So even though I would say an event stream from a button, like handling clicks, is most elegantly modeled as an async iterator, you can't do it um, because it's going to resolve in the next tick of the run loop, and that event is gone, and you can't handle it. So as a result, we're kind of left to do awkward workarounds, and we're back in using callback hell if you actually want to handle events well. And then there's a bunch of different problems too around like caching, where if you want to check something synchronously and make sure that it's in the cache, but then you need to fetch asynchronously. Being able to do that with async functions and a combination of sync functions is it's extremely vexing problem. And if you Google it, you'll see a lot of people being very, very frustrated about it. And and then finally, it just means that every API has to be bifurcated in some weird way. So we have, symbol iterator, symbol async iterator, symbol disposable, single async disposable. And so the other reason I don't like the explicit resource management um, is that it kind of doubles down on this idea of there being two hermetically sealed worlds of sync and async, and you can't communicate between them. So, I mean, it's better than I would say, like if you're going camping in the woods and you're trying to survive, having a tarp is better than not having a tarp. But I would rather have a log cabin, with a fireplace and a wood pile.
Well, I mean, on that note, so Affection is the log cabin with the fireplace and the wood pile. Let's talk a little bit about how Affection solves this problem. And I guess maybe if you want to back up and talk about like if there's like some underlying motivation of like why you built it.
Mm-hmm.
That'd be
Sure,
great to
I can talk about those first. Yeah. So the underlying reason that we built it is that we were working on web front ends. There was actually two projects. We were working on web front ends, and we were at that time using Ember JS, and so Ember had a structured concurrency library, and the patterns that you could do AJAX requests that were automatically canceled, whether you were, closing a route, whether you were repeatedly making a request inside of a autocomplete tab, or sorry, an autocomplete field, or you wanted to manage, the other thing that we used for was managing like 10 concurrent uploads. But if you changed another upload, you wanted to queue it. And if they, again, touching into the other functionalities that I just mentioned, if you exit the page or you exit the route, you want to cancel all of them. The patterns for managing the life cycle of concurrent operations were extremely elegant. I'd never really encountered anything like it. Like the amount of thought I didn't have to expend on tearing stuff down, understanding when stuff needed to just go away, and I could just say, you know what, if it's tied to this lexical scope, that's that's the lifetime of the task. That was my first encounter with structured concurrency, and I was like, okay, this is really, really something here. And then it was shortly afterwards that blog post came out, which I would encourage everyone to read. But then we ended up working on a custom testing framework that was, it itself was an orchestration server that was managing like 5 or 6 different processes. It was also managing a browser, kind of like Playwright. It was also managing a set of simulators that would that would come up, and it was there was a ES build bundler that was also it was managing. So this was, again, taking the pattern from the front end over to the back end. We realized, okay, we can use this structured concurrency back here, because this is just going to be a nightmare if we're trying to manage this all by hand. And so that was kind of the very first version of Effection, was a server conception of this front end framework that we had used in Ember. And as we developed it, the idea of structuring concurrency gained more traction, especially outside of the JavaScript community. And so you have, especially on mobile platforms, where like basically Swift and Java, which are the main development languages for Android and iOS, or I should say iOS and Android respectively. On a mobile platform, you're dealing with highly event-driven code, and so for them, it was very, very beneficial. And so I almost think that JavaScript is a victim of its own pioneering success, in the sense that nobody had async await before JavaScript, and there really is, like, I don't want to bash on it too much. Like, there is a real power in having these suspendable coroutines, and they almost got the story right, but async await came out in like 2013, 2014, and then structuring concurrency as an idea was formalized in 2018. So by being ahead of the curve, I feel like we've kind of also missed the boat a little bit.
Cool. So we've talked a lot about Effection, but like, what does it look like in practice to use? I've looked at some of the other similar libraries in the space, and they're kind of hard to learn. They have a big API surface, but Effect doesn't really seem to have that, or Effection.
So, right. So Effection, our fundamental stance on Effection is that the only thing you should have to learn is structured concurrency and structured effects, or in other words, resources. And everything else should be JavaScript. So people have spent a lot of time learning JavaScript. They've spent a lot of time learning JavaScript APIs. They spend a lot of time interacting with the JavaScript ecosystem. And so we want 99, if not 100% of that knowledge to be applicable to writing Effection code. So if you know how to do something in JavaScript, you're going to know how to do it in Effection. And I think that's very valuable, because if you look at Effection code, it is immediately recognizable what it is that you're trying to accomplish. And with a few substitutions, you can transition from kind of vanilla async await to Effection and back and forth. So I would say that's kind of the primary goal there.
Yeah, I think Andrew made a little Freudian slip to this, but I think the other big library in the space is Effect. Yes. So we had Johannes Schickling on a while back, and he talked about Effect, and Effect is this like amazing library, and it does a lot of things. So it tries to do structured concurrency among like many things, and to me it feels like kind of like Erlang and TypeScript, kind of like it's like really bringing a whole new paradigm, and it is a paradigm shift, and with all the benefits and costs that come along with that. So that's one thing that I do like about Effection, is just trying to like solve this one problem. But there is some good things that Effect does, and I was wondering, things about like, I don't know, does Effection have a lot of opinions about like error handling? So you get the errors in a way that's like that has the guarantees of structured concurrency, but like then you have to like, what is the shape of this error, or like whatever, you're still sort of like responsible for doing all the other stuff, right?
So, sorry, is the question about error handling and difference in error handling?
Yeah. Like, is there any difference in error handling beyond the structured concurrency primitives?
So, I'm not an expert on how FFTS does error handling or how it encourages error handling. I will say this: that the way that you handle errors in Effection is the same way that you handle errors in JavaScript. And that's thematic of the way things work in Effection. So what you do is you put a catch block around your code, and you can catch errors. And if you want to return that error as a value, you can do that, like you would in Rust or Go, and maybe Effect. But it's up to you and your option. So we actually do have a result type that's not, we don't encourage you to use one or the other. My personal preference is I know there's a little bit of a backlash against exceptions. Personally, I like exceptions a lot. I think you have to be mindful of the type of code that you're writing. If you're writing framework code, then it's very appropriate to treat exceptions as values, because in framework code, you are explicitly managing the flow control of other code. And so using exception handlers or using exceptions that unwind your stack is really onerous, because you're actually explicitly dealing with routing that control flow and routing those errors. So if you look inside Effection, you'll see that we always deal with errors as a result object. And we're doing a bunch of checks like, this is okay, proceed, but we're always treating errors as return values. But if you're inside userland, and 99% of the time there's nothing to be done about an exception, then why the hell am I saying anything about it? And I want to be concentrating my exception handling in a single place. And so that's kind of the heuristic that I live by, is if I'm routing errors and the job of my code is to route errors, then treat the error as a value. If I'm not, and there's nothing I can do to recover from an error, then don't. And so that's a long way of saying is you can do both. But the Effection way is that you would handle errors the way that you would just normally.
It's cool that you guys don't bake an opinion in there and like kind of set the two features to coexist with each other. I want to dig into a little on how Effect does its stuff, I want to dig in a little bit to how Effection does all of the magic. You said it's just JavaScript, but it is using the part of JavaScript that probably 99% of people haven't interacted with, which is generators. So how do generators like help with this problem of structured concurrency in ways that Promise can't?
So let me back up, so that the fundamental primitive in Effection, actually, believe it or not, is not the generator, it's the iterator. And what an Effection operation is just a iteration of effects. So you're essentially using an iterator to express a coroutine that can be paused and can be resumed. And so at its simplest case, what you're doing in a Effection operation is you have an iterable of effects, and you pull the effect off, you evaluate it, and when that gives you a result, you pass it as the input to the next effect. And that's kind of, going to wave a little bit of hands here, but that's the way it works. It's the same basic process in Effect.ts. It's the same basic process in like Haskell monadic evaluation. Like this is how you stitch together pure functions with side effects, is you basically have a list of pure functions that are interleaved with side effects where the side effect is evaluated, and then you're passing a pure function, or passing an argument to a pure function, which then gives you your next effect. So all that said, a generator is a very, very clean way to express an iterator. So I like to think of them as coroutines. So it is actually very similar to an async function in the sense that the state of the function can be paused at your yield points, or which is the same as an await point inside of an async function. And then when the effect resolves, you can pass that value back to the coroutine. And as a matter of fact, generators predate async await. So they've been part of JavaScript for a much longer time than the async await has. And furthermore, the async await was originally built using generators because the generators are general purpose coroutines. And what that means, amongst other things, is that because this is the primary way that you express these iterators in Effection is with generators, you are able to express a general level of effect with your yield than you can with an await. Because an await is basically a special case of a coroutine resumption that is only this. It's an effect that can only track promise resolution or promise settlement, whereas at a yield point, there's an infinite number of effects that could be resolved. And so you see this actually in Effection. Not everything is an asynchronous operation. Sometimes what we're doing is we're getting something off the context, and that's a synchronous effect, but it's a similar idea. So it's actually infinitely more powerful in a way. So it predates. It's actually simpler than async await, and it's many orders of magnitude more powerful. But this is actually something we try and point out a lot. It's just JavaScript. Every browser runtime supports it. You don't need any build tooling. It's all built in, and it's really fast.
One thing that I was wondering about is one of the hardest things to deal with promises is just debugging asynchronous code is challenging, especially because it'll split. And a lot of times you get like split stack traces because it's like, oh, something is getting queued up and the event loop like handles this at some later time and something fails. And you're like, well, how did this even happen? Where do I find actually what like called this? So do you find with Effection, you're able to like, I don't know, when an effect in Effection fails, is like there a better stack trace? Like, I don't know, how does that work?
So the answer is yes, and the answer is it's going to get even better. So right now, this is because we're using generators, and which is fundamentally harmonious with the underlying runtime. Node, V8 and JS Core and all the JavaScript runtimes, they'll generate those stack traces for you. So an understanding, I've got this thing that called this thing that called this thing. Whereas if you're using a callback, and I've got your stack trace what you're seeing is the entry to the stack trace from your your TCP event handler, and you're like, what? And the stack trace is two levels deep, and it doesn't really tell you what was going on. Effection will actually give you the stack trace, providing you're using the generator syntax, just the same way that you'll get it with the await syntax. One of the problems, if you've ever used like observable.js, this is one of the biggest RxJS and observables. One of the biggest complaints is like I can't get stack traces because basically you're just getting context-free function calls that are coming from some callback somewhere. If you could look on Stack Overflow, you'll see 1,000 questions complaining about this. I think systems like, if you're going to use a system based on functional composition at the core level, like we're using functional composition at the base layer, and then we have the generators on top of it. You're going to need extra tooling to capture where an operation originated from. Whereas that just kind of falls out naturally inside of Effection. And I think it's one of the whenever people use it, they're like, wait, these stack traces are actually discernible and they work, and like, wow, that's revolutionary. And but it's part of our whole approach is trying to be as sympathetic with the underlying platform as we can, because it means that you're just going to be at greater sympathy with all of the ecosystem, including the development tools and including the third-party libraries.
Yeah, the fact that the stack traces are readable is so huge. I'm a React developer also, and it's the same problem where it's like, oh, my function got called, and then below that is 15 frames of what React was doing, and I'm like, I don't care, I don't care.
Right.
So you mentioned it's going to get better, and I know you're working on a V4 release of Effection, which I'm really excited about. So can you kind of give us a teaser of what's coming up in V4?
Yeah. So I would say what you can look forward in V4 is everything and nothing at all. And what I mean, let me start with the nothing at all. So the amount of the changes is going to actually be very small. So the API, the public API surface is not really changing at all. In fact, we're in the process of backporting a lot of the V4 APIs back to V3 because we find, one, they're very, very helpful, and two, that it's going to make it a much easier upgrade if those APIs are already available. So Effection is not a very big library. It's maybe 20 functions, and it's 4.5K of compressed JavaScript. So it's not going to be changing on the outside very much. On the inside, it is going to be changing quite a bit. So originally, we had written our own delimited continuation library to build Effection on. And so what we can get in, that's a whole another can of worms of what a delimited continuation is. But it's a concept from functional programming. But as a result, we have built this iterator composition library on top of another iteration composition library. And so it's very confusing of what context you're in. All of that has been brought in to Effection v4 so that we have the delimited continuations are native and they're all implemented, and it's very clear what type of code you're working on. The second thing, and this is where you're getting into more of again, these are very, very subtle details. There's a single run loop basically there's a single run loop for the entire Effection stack. And so what happened before in V3 or what happens now in V3 is every single task will have its own run loop. And so it's possible to have non-deterministic evaluation of event resolution. In V4, everything is put into an absolute queue. And this means that things are more deterministic, but it also means that we can actually prioritize certain tasks over others. So for example, parent tasks are going to be in parent operations always have priority. So if you have two events that resolve while you're evaluating something else, the parent task will come in front. And what that means is if the parent is going to do something that's going to cancel the child task that will never run. So it's actually really important for supervision and for kind of enhanced guardrails of structured concurrency. The parent always gets to decide the lifetime of itself and its children. The other thing is that we're going to be having one where we have a way to represent. This is another subtle point. Let me just put it this way. The stack traces are even better. So actions and function calls and tasks and resources all got their own iterator in Effection v3. Now only a task and a resource is going to get its own iterator. Everything else is done within the same iterator. And so what that means is if I'm invoking an action or I'm calling an async function or I'm doing something like that, Effection v3 will reset the stack, and so you'll get kind of the stack will be segmented along those lines, and so you won't get the complete picture. Now you will. So that, we that was one of the kind of the harmonious effects that we realized was we were working with Effection. Like the stack traces are really great. So we're like, can we make them better? The answer is yes. And then I would say the last thing we can expect on V4 is it's much more performant. So Effection's already performant. It's actually really performant, but we add some benchmarks, and it consumes less memory and goes faster.
Sweet. We like thin abstractions here.
Yeah.
Before we wrap up, we always like to ask a future-facing question, and for you, we're kind of at this dawn of this structured concurrency trend. Like we're a few years into it now. Do you think it's going to change how we program? Is it going to banish promises and async away from our code, or is it going to take a little bit more?
I think it absolutely is going to change the way that we program. I think that in 10 years' time, this will be the expectation of a runtime, is that it will have structured concurrency. I think any new language that's going to come out after the next couple of years will have structured concurrency in it. In the same way that it was very controversial structured programming in the 60s and 70s. People are like, you will take my go-to statement out of my cold, dead hands. Like you just can't take it away from me. It was very, very controversial. And yet now in hindsight, it's like very obvious. But there's always going to be people who are invested in a particular technology because they have a huge sunk cost in learning it and developing an expertise in that. But I do very much believe that async as we know it, we might see async keyword. We may see the await keyword, but it won't mean the same thing in JavaScript, because eventually what JavaScript has in the form of the new promise constructor or being able to invoke an async function without binding it to a context is you essentially have the concurrent equivalent of a go-to statement.
Yep, I was thinking that earlier in this episode, that it very much feels like a go-to, but like just not even, almost just not even explicit. It just seems like you're doing the same code. Well, thanks for coming on, Charles. This was a really fun dive into Effection. You've built some really cool stuff here, and I'm definitely going to be taking a look at it next time I'm doing any type of async programming. So thanks for coming on and talking about it.
Yeah, please do. I mean, our whole stance with Effection is, in fact, the name Effection is about warmth towards the JavaScript language and the JavaScript community, and talking about that platform sympathy. So it's actually baked right into the name. Is making sure that it's as easy to work with if you know JavaScript. So please, if you're having trouble with asynchrony or even not, just give it a try. Come in, jump into our Discord, start a discussion or file an issue on GitHub. It's a great time.
Yeah, thanks, Charles. Effection is like one of the libraries that I like keep coming back to for inspiration again and again. So I'm excited to use it in some of my upcoming projects. And yeah, it's a great library. I really recommend people check it out. And I think you've done something really powerful here in like a really small footprint, which is also pretty incredible. So yeah, good work.
All right, thanks, y'all.